Great pleasure to introduce Valeria Giardino, who is a permanent researcher at the CNRS, the National Centre for Scientific Research, and at the Institut Jean Nicod, a great source of philosophy of mind and cognitive science in this wonderful city. Valeria works on diagrammatic reasoning, mathematical reasoning, embodied reasoning, on gestures, and doing some amazingly interesting work on the evolution of cognitive technologies at the moment as well. We're also going to hear from Valeria on a different bit of her interests tomorrow in our wrap-up roundtable session. But today now, Valeria speaking, we are geometric beings, how we use space to think. Thank you.
Thank you very much, John, for the invitation. I'm glad to be here with all of you and discussing all these very interesting things about space. So I will go straight to the kind of objects that I'm interested in my research. So this is a kind of diagram that is used in topology, in low-dimensional topology. So we are doing geometry. Remember that topology, you can deform space, and metric doesn't matter. So here we have a square, but we could have had the rectangle, doesn't matter, but we like squares, and we'll go back to that. So the arrows that you see are indicated some operations that you are supposed to perform, to do. So you have to identify the two sides of the squares in the direction of the arrows. So try to imagine what you are supposed to do. Here, this is a surface. Which kind of surface will it be? So you imagine that you have to stretch this square and then glue, as the jargon in topology goes, glue these two sides. So I hope you agree with me that you will get a cylinder. And the important point, so that's the thing that you have to imagine. And the important point is that already in the first diagram, you have the cylinder. It's already a surface. It's already the representation of a cylinder. So just for fun and for philosophers, in particular if you're doing metaphysics, this is another surface. So you are doing the same, you're supposed to do the same thing, but instead of gluing the arrows in the direction of the arrows, you have to glue them in opposite direction. And I suppose that you maybe you're already familiar with this, but you will get a Mobius band. So just to get more fun, this is an example of construction in low-dimensional topology. So again, this is a surface. And the fact that you have arrows of with different features colored differently just indicates which couples you have to glue first. It doesn't matter the order because it's not important, but it's just giving you the couples. And so bear with me, you do the same kind of operation that you did before. So you obtain a cylinder, and then imagine that you stretch the other sides of the square, so the sides of the things that you have here indicated by the other white arrow, and you have to glue them. So I don't know if you have any idea of what kind of surface this is a representation of, but you will get a torus. So you're stretching things because you are in topology and you can imagine all these kind of things. So of course, this visual representation can be formalized. It's a quotient of a unit square d squared over tilde, where tilde is defined by the following relations. But the point is that without the visualization that I gave you before, you wouldn't be able to understand this formalization at all. So there are many questions to be asked starting from these kind of objects. First of all, we might ask, what does this example tells us about our way of doing topology, about our way of doing geometry, because of course topology is a branch of geometry. What does this example tell us about mathematical reasoning in general with these objects? And what does it tell us about our way of using the space of these objects? Because I told you, I gave you some instructions on how to interpret them and how to use them. There were some actions at play. You had to imagine some particular manipulations. There were some objects that were emerging because we ended up with a torus, which is quite a peculiar object. So how do these kind of objects work together, and how can we use their space to think? So in my talk, which should be very brief, so I will be a bit quick, and we can go back to some of the issues in the discussion. I will give you just very quickly the philosophical background on what I'm working on. Then we will look at 2 instances of diagramming. One of it, it's joint work with the wonderful Barbara Tversky. I'm very happy he's with us today. And then I will really try to end with this idea that there are several levels that we have to disentangle when we want to understand how we use space to think. So, philosophical background, we discussed already the fact that human cognition might be embodied or extended. But what do these metaphors imply? And it's true that there might be some problems with some possible misleading interpretations of them. For example, this idea that the extended mind is externalizing something that is internal, or that there are some kind of external vehicles or processes that are cognitive just because they are similar to what's going on internally. But this is kind of not satisfying if you want to make sense of the kind of the use, of the cognitive use that we make of the objects that I showed you, because of course they were external, of course there was something internal that we were doing, but it looks like the things that we were doing internally were kind of shaped by the objects that were external and that have been provided by culture, by mathematics, and so on and so forth. So that's why, as a framework, I move in this kind, what has been defined by John as second wave of the extended mind thesis, according to which we have to think in terms of some kind of complementarity that there is between external processes and vehicles. And they can be with external processes and internal processes in such a way that these vehicles can be different from the internal processes that we might have. We can go back to that, but the idea that I had, and that's why I talked about this idea, this faculty that I defined as diagramming, is that as human beings, we recruit several systems that are already available for us for perception or for action. For example, the visual spatial system, the conceptual system, the motor system. Think again of the examples at the beginning. There were lots of things that we were working, that were triggered by these examples. And we are trying to establish, we are able to establish an external connection between all these systems by means of some particular cognitive tool. And the role of these cognitive tools, such as the diagrams that I showed you before, is to trigger such a connection. And this is what enhances inference and reasoning. And so we learn to think in a different way. This is kind of, there are similar ideas or close ideas. So I'm happy to quote this passage from Barbara's book. And I'm quoting, she says, we see that our actions in space design the world, that the designs create abstract patterns that attract the eye and inform the mind, that the actions get abstracted to gestures that act on thought, and the patterns to diagrams that convey thought. Actions in space create abstractions, a spiral we call spraction, impossible to be translated in Italian or in French, but I like it as it is, so no need to translation. So, are we geometric beings? There are lots of things that I talked about, diagramming, spraction, gestures, patterns, diagrams. It looks like we have to map all these different elements of spatial cognition that matters in all these cases. I will show you very quickly 2 possible instances of diagramming. One is the case of gesture in thinking, and the other one, I'll go back quickly to the diagrams in math. About gesture for thinking, so again, this is joint work with Azadeh Jamalian and Barbara Tversky. So what about gestures for the self, to think? There's been a lot of work about gestures in communication, so in a social context. We know that they help communication, but what if we think of thinking as kind of communication with the self? Can gestures help us think? So what we did in order to give first reply to this question, we did this experiment when we asked to the participants to learn some environments from linguistic descriptions. Participants were alone in a room, which was important because if not, they were not using gesture. And they were not aware that we were interested in their gestures. We just told them that it was a test of memory and of inference. So they were looking at some description. They had to read some descriptions of some environments, outdoor or indoor, large 8 landmarks or small 4 landmarks. So just to be sure, I'm clear when I say 8 and 4. They were just there were we realized that if we were going beyond 8 landmarks, it was getting too difficult. So that was our choice. They were given in spatial descriptions, and the descriptions were given in 2 ways, which are typical in studies on navigation. So either they were given in a route way, so they were describing the action of the person that is navigating the environment, so he's seeing things left, right, behind, in front of him or her. Or survey, survey mode that meaning that they was using extrinsic coordinates like north, south, east, west. So this is an example of a large environment in a route description, just to show you what they were, to give you an idea of what they were looking at, and this is a small environment in survey description. So let's look at one of the subjects. He's reading. So again, he didn't know that we were interested in gestures, and what he knew was that he had to memorize the features of this environment. So as you see, the videos are clipped. So these are the gestures that he was and as you see, there is no keyboard because the keyboard was really not helpful. Once they had the hands on the keyboards, they weren't gesturing. And another thing that he's doing is, yes, exactly. So he will say next to go to the next slide because that's what we use to avoid the use of the keyboard. Afterwards, so they read the environments, and then they had to respond to the truth or falsity of some statements. And these are the kinds of statements that we were giving them. And this is an example, another video of one of the participants who was responding to was replying to the statements. She's very rare because she's one of the rare participants who's really even moving her body in order to reenact the environment, which was not typical. But as you see, she as well, she's kind of drawing a map. So there are many things that also we discussed afterwards about the kind of shape of the gestures that they were making in order to. One important thing about the statements is that some of the statements were taken from the environment, like verbatim, and others require some inference. So they were gesturing also to that. So what were the results? Did participants gesture? Did they perform better when they gestured? And we got 2 yeses here. So they mostly gesture, both in reading the environment and in replying to the questions, and they perform better what they did. So why do gestures improve memory? There are some possible answers to that. So of course they offload memory, they structure memory to some extent in this case. And also what we found very interesting is that they provide also an alternative code, because I didn't say that when I was showing the video, but like the subject, the girl, she looked at her hands. But this was, again, very rare. They tend not to look at their hands, so it looked like there was not a visual feedback, but it was more like some kind of propositive information. So gesture would provide an alternative code because of this, and it looks like the alternative code is kind of spatial motoric. So, but what happens when we go from gestures to diagrams? I can go back to the experiment if you want in the questions. So gestures are transitory and private, but what does it happen when we start leaving traces? So when it's not only a gesture, but it's a diagram. And I think that here you have new forms of diagramming. So first of all, you can have sketches, which are more stable externalizations. They can be shared, they can be manipulated, but still are idiosyncratic. And then you can have diagrams. Of course, diagrams can be defined in many different ways, but I use it as a big umbrella term. And in my way of defining it, diagrams are objects that are durable, they are public, they are cultural objects, and they give instructions on how to manipulate them, as in the examples that I give you at the beginning, and I will go back to that. Why the interest in mathematics, among other reasons? It's because in my view, actual mathematical practice is a key explanandum of any account of reasoning through spatial cognitive tools. So what do we mean when we talk about cognitive artifacts? And this also resonates to the previous talk, with the previous talk. So I like this quotation from Jack Goody, who talked about, in particular, is we're working a lot on writing, as some of you may know. And here he talks about the mathematical table as essentially, and I'm quoting, the product of writing, but one that can be taught to and learned by those who can neither read nor write. And yet it provides those who use it with a special cognitive tool, a technology of the intellect. You mentioned this idea of cognitive technology. So artifacts of this kind are a kind of technology for the intellect. And also I like to quote a passage from a German philosopher, Sibylle Kremer, who used this term of operative iconicity to refer to the way in which diagrams are used. I'm quoting, so she says, considered writing, tables, graphs, diagrams, or maps, as the one of the Saint Louis, saying and showing work together in the diagrammatic to create an operative iconicity. And what does she mean by that? Is this idea that in things like the map or the objects that I showed you at the beginning, you have at the same time something that is a representation for something, but at the same time is an instrument to work on what is represented. So the thing that I particularly like of the case of the topological diagram, and I'll go back to that, is that at the same time you have the instructions on how to construct the surface and also a way of working with it, of imagining things on it. And that's exactly the point that I want to make, and I think it's my last point. So let's go back to the first, to the examples that I gave you at the beginning. So in philosophy of mathematics, it's very rare to talk about notation, but there's an introduction to philosophy of mathematics written by Mark Collivan, who has a chapter on the role of notation. And I'm quoting from him, and he says something about, in particular, about the examples that I gave you. And he says, this algebraic topology notation is something of a halfway house between pure algebra and pure geometry, because it is both notation and a kind of blueprint for construction of the objects in questions, in the kind of way that I mentioned when I talked about operative iconicity. So it's at the same time something you can calculate on, and also something that gives you instruction on how to construct the surface. The first seems to belong to algebra, while the second is geometric, but whichever way you look at it, we have a powerful piece of notation here that does, and that's what he says, some genuine mathematical work for us in the ways that I hoped I have showed you. Okay, so if you want to play, I mean, this is the kind of things that I would like to allude to. So imagine that you have squares, you have squares, you have arrows, you have directions, and you say, okay, what if we change one of the directions of the arrows? We did already the same for the black ones, but let's change also the white ones. And what you get is a very interesting object that is very difficult to imagine, which is the Klein bottle. Which is a three-dimensional object, but it needs 4 spatial dimensions for its construction, and has no inside nor outside. Let's say it's a kind of three-dimensional version of the Mobius band. And what I would like to think, I mean, this is not the way in which the Klein bottle was discovered, but I would like to think that it's thanks to the diagrams that you can also make new objects emerge. And this is a question that it's part of my work. So the idea that a good notation in mathematics is far from being trivial, because it not only facilitates calculation, but would play a role in prompting new ideas and inducing new developments in mathematics. There was a talk about affordances, so thank you very much. You talked about that already, and I think that this resonates with what you were saying, but I think that another discussion of the role of affordances could be done for notations in math or other kinds of objects. So diagrams and notation as well would afford certain actions on them. like the fact that you can imagine manipulating them in some particular way. My idea is that there could be two levels of affordances. Some depend on our cognitive system. For example, we like symmetries. Again, we like squares and not maybe more than rectangles. Another would depend on the practice and would be recognized only by the experts. I mean, only if you know that what the arrows means, you know what the affordances is. And the point is that a tool would be well designed only when this kind of two affordances to some extent will correspond. So I'll get to the end. I know I'll be quick, but I can go back to some of the things, to all the things that I said. So my point was, if we want to look at the way in which we use space to think, I think it's very important to disentangle between different kind of practices. One is navigation, but I haven't talked about it, but it's like the degree zero. And then you have forms of diagramming that becomes to appear. So you have gestures which are transitory, private, and it goes back to what Barbara Tversky says when she talks about spraction. And then you can go to new and more sophisticated forms of diagramming when writing appears. So you can have sketches, which are more idiosyncratic, and this is, again, the patterns in the gesture that are reused once they leave traces. And then you can have diagrams, which are stable, which are public, which are cultural objects. And here you can have cases of operative iconicity. And this is it, because this is the time that I had, but we can go back to that. And if you're wondering what the Klein bottle looks like, this is it.